A stone thrown upward with an initial velocity of v naught equals 128 feet per second from initial height of h naught equals 0 feet follows an equation for its height in feet as a function of time, y of t equals negative 16t squared plus v naught t plus h naught. Determine the parts a through f. So our position function of time, the height in feet as a function of time, is negative 16t squared plus v naught, which is 128 times t, plus h naught, which is a 0. For part A, we're going to determine the velocity as a function of time. The velocity as a function of time is the derivative of the position as a function of time. The derivative of the first term is the power rule, bring down the power, 2 times the negative 16, negative 32, t, subtract 1 from the power. The second term is a constant times t, the derivative will be the constant. There's our velocity as a function of time. For part B, we want to find the time when the velocity is a 0, so we're going to take that expression we just came up with and set it equal to 0, and solve for t. Let's start by subtracting 128 from both sides. We will now want to divide by negative 32 on both sides. And we have negative 128 divided by negative 32. That comes out to a positive 4. The time can be determined over here from the initial velocity, it's feet per second. The time unit is seconds. Part C, we want to find the maximum height reached. The maximum height occurs exactly at the moment in time when the velocity has become a 0. The stone at that point is in the process of turning around from having moved upward to start moving back downward. And that time is at 4 seconds that we found in part B. The maximum height is going to be the height reached at that exact time, so y of 4. We will have negative 16 times 4 squared plus 128 times 4. 4 squared is 16. Plus 4 times 128, that comes out to 512. A negative 16 times a 16 is a negative 256 plus 512. And negative 256 plus 512 comes out to 256. We're in units of feet. It can be seen over here from the v naught and the h naught. So this will be 256 feet as the maximum height. Part D, the time when it reaches the ground again. The ground is defined as a height of 0, and therefore we want the height as a function of time to equal 0, so negative 16t squared plus 128t set equal to 0. This can be factored. There's a common factor of a negative 16 and a common factor of a t. If we factor that out from the first term, we end up with t. From the second term, 128 divided by negative 16 is negative 8. And the t has been factored out. So we have two solutions here, t equals 0 as well as t equals 8. The t equals 0 was the initial time that the stone was at the ground. We want the later time, that'll be the t equals 8. That's when it reaches the ground again. So t equals to 8 seconds. For part E, we want to know the velocity when it reaches the ground again. Well, we just found the time when it reaches the ground again in part D, and we have the velocity as a function of time in part A. We want to evaluate that at the exact time we just found in part D, so v of 8, which will be negative 32 times 8 plus 128 Negative 32 times 8 is a negative 256, and then plus 128. Combine those together, will end up being negative 128 units of feet per second. The negative is indicating that it's headed downward, which is no surprise. It has gone up to a maximum height, turned around, and has come back down to the ground, and so it should be headed downward at that time. Part F is to find the acceleration as a function of time. The acceleration as a function of time is the derivative of the velocity as a function of time, and therefore the second derivative of the position as a function of time. We have the velocity as a function of time in part A. If we take the derivative of that, that will give us the acceleration as a function of time. The first term is a constant times t. The derivative will be a constant, so it'll be negative 32. The second term is a constant with no t. The derivative of that is a 0. So we have negative 32. The units of acceleration will be the length unit of feet, and then over the time unit squared, time in seconds. So negative 32 feet per second squared.